Hello, this is Lightning Matt at Lightning 3D Creations, and welcome to today's video. Today I am showcasing a quick guide on the problem with my JGAurora A5S filament sensor. For a few months, my A5S had experienced the filament sensor fault that has been previously reported by many people. It would stop in the middle of a print, giving the filament break failure message, when the filament was still intact. Each time I was able to restart the printer without doing anything to the sensor. Sometimes this would happen multiple times in a short period, very aggravating. Some people reported fixing the issue by shorting out the sensor at the main board. While this would bypass the fault, it does not allow the unit to protect itself when there is an actual break in the filament. Before getting into the problem and fix, allow me to explain the basic operation of the filament sensor signal. The A5S has a similar filament sensor as the previous A5 models, and likely similar to other JGAurora models. I am not familiar with their entire line of printers. You would need to verify if this fix is correct for your particular printer. Also, the main board for the A5S is different from earlier A5 boards. The wiring to the board uses a different connector. The fix I am discussing for my A5S should work on the A5 board if the fault seen is the same. The filament sensor circuit is a standard limit switch wired in a normally closed arrangement, as shown here. The filament presses against the bearing, which then presses the limit switch, shutting the switch. As long as the limit switch is shut or closed, the signal will stay on and the printer will continue to operate normally. If there is a break in the filament, the switch will release and the signal will go off. The printer will switch to the filament break failure mode. On the A5S and similar build types, the wiring has a number of connections in the circuit. This is done to allow for easy assembly by the end user. Unfortunately, when you increase the number of connections in a circuit, you increase the risk of a bad connection. If any one of these connections vibrates loose, even for a fraction of a second, the circuit will open and the printer will switch to the filament break failure mode. An intermittent fault due to a loose connector would cause this failure mode. That is what I theorized was occurring on my printer, and seems to be why a lot of people report that their printer is giving the failure indication, but the filament is not broken. Now, let's step back for a minute and discuss why a possible loose connector does not affect the rest of the circuits on the unit. First, every other limit switch on the unit works in a normally open mode. The various stops only close when the unit reaches its associated mechanical stop. The printer immediately backs off the stop once the signal is received. If the fault is intermittent, this will likely not be noticed, as the limit switch only needs to send a signal for a fraction of a second to tell the printer it is at its stop. The hot end heating element is also wired through these connectors. With an intermittent fault, the element would only see a momentary loss of power, which would not significantly affect its operation. That's how the heater is kept at the correct temperature anyway, by cycling power on and off rapidly to control the temperature. The hot end thermistor may have a minor issue with an intermittent failure, as the control circuit would see the temperature suddenly drop. With the intermittent fault, the signal would come right back quickly. The heater control would not vary much. You could see minor fluctuations to the temperature. In this case, most people would assume a faulty thermistor. Finally, the motors. For this type of intermittent failure, this would be the most apparent spot other than the filament sensor. If the stepper motor does not receive its signal to move for a brief moment, it will not respond as the G-code thinks it is responding. This could lead to minor shifts in the layers. For example, if one of the Z motors is affected, it would not lift as high as the opposite Z, and the layer on that side of the board would be slightly closer to the previous layer than the opposite side. Or if the X-axis motor is affected, it could throw off the print head location slightly, thus a shift in the layer. Why don't we see these layer shifting problems though? Well, two things. One, the intermittent failure would have to occur at exactly the moment when the servo motor is receiving the signal to move, which can still occur, but would limit the periodicity. Two, I think we do see them. They are just so small instances that they are unnoticeable. Or if it is noticeable, we write them off as another issue, such as a bad stepper motor driver signal. Also, for all of these situations, we would have to assume that multiple wires are loose. Not likely the case. This type of intermittent connection failure usually only affects connector pins that are loose to begin with, and usually the ones at the ends of the connectors, where there is more flexibility in the connection. Many of the pins on the connector may be correctly installed tight and making good electrical connections. In order to prove out the intermittent failure mode, I disassembled the printer and checked the circuit. The limit switch, as shown here, is a standard type used in many applications. It was in good mechanical condition and tested good. The rest of the sensor assembly was in good shape. The bearing that presses on the switch fit smoothly in its retainer and moved freely. Next, I took a small piece of filament and cut a section to approximately half thickness. Inserting the filament into the sensor, it properly actuated the switch. Even the thin portion kept the limit switch closed. Following that, I tested across the various connectors with a multimeter. I found all connections good when the printer was not running, and I was making good connection with the meter tips, i.e. pressing into the connections with the meter tips was likely helping the connections stay tight. Next, I reassembled the printer and tested the circuit from the switch to the board. I did this by connecting test leads to the plug at the board and passed them through the Y gantry slots. Then I connected the meter to the terminals of the switch. Then I wiggled the connector on the side of the printer. The meter indicated and opened for only very brief moments, hardly enough for someone to catch. I put the meter in diode test mode, which gives an audible beep when the circuit is initially made, and tested it again. Sure enough, while wiggling the connectors, the meter beeped multiple times, an indication that the circuit was being broken and remade. Thus, I believe I located the intermittent fault. Following the testing, I decided to run new sensor wires to bypass the connection. I took a length of signal wire that I had available and used the connectors from the old wiring to create one long wire that would plug into the main board and the sensor limit switch. I did not have spare pins for the connectors to properly rewire them, so I left a small portion of the old wiring on the connectors, then spliced and soldered the new wire to it. Then I insulated it with shrink tubing. Next, I drilled a hole to pass the wire through and keep it away from the other moving parts. I reassembled the printer, routed the new wires up to the sensor, zip tying it to the existing cable run, and tested the system. Also, I should mention, I used hot glue on each connection to prevent them from vibrating loose. The printer started fine with no errors, specifically no filament break failures. It has since run for more than 30 hours of print time over the past month with no other failures. I'm calling this a success. Thank you for watching. This is Lightning Matt from Lightning 3D Creations, and have a great day.